The most advanced space telescope ever built is the James Webb Space Telescope. In this video, we'll explain how this telescope works, how it was designed and put together in different parts of the world, and we'll look at its launch and journey into space. Looking up at the night sky, we can only see a little with just our eyes. When we leave the city and its lights behind, we can see a bit better. But if we want to see even more, we need to use a telescope. A telescope lets us see much farther and with better clarity into the night sky. There are many types of telescopes, but in this video we'll focus on a simple reflecting telescope. It uses mirrors to catch and direct light. Light enters and hits a large curved mirror, then bounces and is focused onto a smaller secondary mirror until it reaches an eyepiece for us to see or a camera to record the images. Think of it like collecting rain. The bigger your bucket, the more rain you will collect. The larger the mirror, the more light it gathers and the farther away objects you can see. A space telescope works on the same idea, but on a much larger scale. Looking into the vastness of space is a bit like looking back in time. Let me explain. Light travels quickly, but it does not travel instantly. Light from the sun takes about 8 minutes to reach Earth, covering a distance of 149 million kilometers. If something suddenly happened to the sun, we wouldn't know it for 8 minutes. The star closest to us is just over 4 light-years away, which means we see Proxima Centauri as it was 4 years ago. Imagine looking at other stars that are thousands or even millions of light-years away. With a strong enough telescope, we can see galaxies that are billions of light-years away. It is like a time machine. We are looking back into the universe as it once was. This helps scientists answer some very deep questions. It might also help us understand more about Earth and why it formed the way it did. Telescopes on the ground see light only after it passes through the atmosphere. The air has shifting pockets that can blur images and even block some types of light from reaching the ground. You can overcome some of these issues by placing telescopes high in the mountains. We call this an observatory. But for the clearest view, scientists have put telescopes far above our atmosphere. Getting anything into space is challenging and costly. There have been many space telescopes over the years, in different sizes and launched for different reasons. Keep in mind that this is not a complete list by any means. The most famous one you probably know is the Hubble Space Telescope. Hubble was launched in April of 1990 aboard the Space Shuttle Discovery. It was a 5-day mission in orbit around Earth. The 5 NASA astronauts on board worked together to deploy the Hubble Space Telescope. Hubble is in low Earth orbit, about 540 kilometers above Earth's surface. When we look inside this telescope, we see that light comes in and bounces off the primary mirror. Then it goes to the secondary mirror and gets redirected through the center to the science instruments at the back. These pictures are then sent back to Earth. Hubble was able to see much farther into space than ever before. In December of 1995, they did something now known as the Hubble Deep Field. Scientists pointed Hubble at a part of the sky that looked empty. As far as we knew, there was nothing there. They kept looking at the same spot for days to collect as much light as possible. What they found was amazing. It was filled with faraway galaxies. Moments like this changed the way we look at astronomy. There is so much out there to see. Because Hubble is in low Earth orbit, astronauts could return to it for repairs and maintenance. There have been 5 servicing missions, with the last one in 2009. Each time, the space shuttle would catch up to Hubble and make the needed repairs. Then astronauts could open it up and fix or replace parts inside it. The last servicing mission was in 2009, and the space shuttle retired in 2011. There isn't really another way to repair Hubble. As of December 2024, Hubble is still working, but it is unclear how much longer it will last. It was well known that there were limits to what Hubble could see, no matter how long it stared at the same place. It turns out that light comes in different wavelengths. This is called the electromagnetic spectrum. You already know some of these: longer wavelengths for radio waves to listen to music, and shorter wavelengths to see if a bone is broken. The human eye can only see a very small part of this spectrum. Our eyes take these different wavelengths and see them as colors. The rest of the light we cannot see, at least not without the right tools. A good example is thermal vision goggles. Watch what happens when we use them. I can see that there is a person inside the house. The goggles let me see the infrared light, which shows the heat of different objects. That light is still there, but without the goggles, humans can't see it. Infrared light is just above what we can normally see. Hubble is an optical telescope, which means it can mostly see what our eyes see, but much more sensitively. However, scientists have long known that if we only look at visible light, we miss much of the picture. This is the James Webb Space Telescope, sometimes called JWST or just Webb. It was launched in December of 2021, so it is still new. It is an infrared telescope, which means it can see beyond visible light, showing things even Hubble cannot see. Our understanding of the universe is that it is expanding. Galaxies are moving away from each other. When we view galaxies that are far away, they move fast enough that their light waves stretch. This effect is called the Doppler effect. That means what used to be visible light is now shifted into the infrared. This is known as redshift. It is no longer light we can see with our eyes, and a telescope like Hubble cannot see it. Hubble can see a bit of infrared and ultraviolet light, but mostly just visible light. Webb was built to observe these faraway objects, basically looking far back in time to see the universe as it once was. Consider stellar nebulas or gas clouds. Hubble might only be able to see their outer parts, but Webb can use infrared light to look inside and reveal amazing views. Webb is not in orbit around Earth like Hubble. It is about 4 times farther away than the Moon, roughly 1.5 million kilometers out in the dark cold of space. So why put it so far out? Webb is placed near a Lagrange point, a spot in space where gravity and other forces are balanced. When a spacecraft is placed here, it needs a lot less fuel to stay in position. For Earth and the Sun, there are 5 Lagrange points, and L2 is ideal for placing the telescope. It is still close to Earth, but far enough away so that sunlight does not disturb its operations. The telescope is set to detect infrared light, meaning its instruments are very sensitive to heat, even their own heat. They need to be in a cold, dark environment to be able to see those very distant stars and galaxies clearly. Honestly, Webb doesn't really look like a traditional telescope. When we look at Hubble, we see the long tube shape that blocks out extra light to better focus on distant objects. In contrast, James Webb Space Telescope is clearly different. It is located far from any sources of extra light, and the sensitive parts will never be hit by sunlight. The diamond shape you see is called the sun shield. It is about the size of a tennis court. It has 5 layers, each about as thick as a human hair. The instruments on one side must be kept dark and cool for them to work properly. The James Webb Space Telescope will always be pointed away from the sun. If it ever points even for a short time toward the sun, it could damage the instruments because they are so delicate. Below the sun shield is the spacecraft bus. This contains the electronics, communication systems, and propulsion systems. Above the sun shield, the telescope is divided into 2 parts. The ISIM is at the back, and the OTE is at the front. There are 18 hexagons that make up the primary mirror. We use hexagons because they can be built in parts and then assembled without any gaps. The side pieces then fold, making it much more compact for launch. This design allows us to build a much bigger mirror than was possible with Hubble. Light bounces off the primary mirror and then onto the secondary mirror. The light then enters the telescope and reaches the science instruments. There are 4 science instruments in the back, each with a slightly different job. Webb's instruments allow it to detect the oldest and farthest objects in the universe, and they also study how stars and planets form, as well as observing objects within our own solar system. So how did Webb get into space? Let's go back in time. Hubble was launched in 1990. Just before that, there was a meeting to plan the next space telescope. It took some time to get started, but construction finally began in 2004. There were many delays, and the project was almost cancelled in 2011. It took a lot of teamwork to build and test the different parts of the telescope. After many delays, it was finally launched in 2021. Webb is expected to last about 10 years, but if all goes well, they hope it can operate for at least 20 years. This is an international project. We have NASA in the United States, the Canadian Space Agency from Canada, and the European Space Agency, which includes contributions from many different countries. The hexagon mirror segments were made in several locations in the United States with the final assembly done in Boulder, Colorado. They are made of beryllium, a chemical element that is light, strong, and will keep its shape even in the cold vacuum of space. There is a very thin layer of gold on top, used because gold is a good reflector of infrared light. The mirror segments were then shipped to Greenbelt, Maryland, to be integrated with the telescope. In Huntsville, Alabama, work began on building the sunshield layers, which were then shipped to Redondo Beach, California. The sunshield has to be folded up small enough to fit inside the rocket. The top parts of the telescope, the OTE and ISAM, were also built in Greenbelt, Maryland at the NASA Goddard Space Flight Center. Here you can see the basic structure. You can see the hexagon shapes where the mirrors will be placed. They used a giant robotic arm to handle all the heavy lifting. It carefully lifted the mirror segments and placed them on the frame. This took about 3 months to put in every mirror. Then, the clean room workers were lifted up to carefully remove the black protective covers. It is very important to keep these mirrors in perfect condition, free from scratches or dirt that could blur the images. Inside the clean room, they also installed the science instruments, the ISAM and the OTE. Together, these are known as OTIS. When it was time, OTIS was packaged into a special shipping container called STARS. The package was then loaded into a C-5 airplane and flown to Houston, Texas for extra testing at the NASA Johnson Space Center. There, they unpacked the telescope and prepared it all. Inside a large circular door called Chamber A, the largest high vacuum chamber in the world, OTIS spent about 100 days for cryogenic vacuum testing. This means all the air was removed and it was made very, very cold to ensure that it can survive the harsh conditions of space. After this testing, OTIS was packaged up again and flown to Redondo Beach, California, where the final assembly was completed at Northrop Grumman. This happened in August of 2019. After some final tests, the James Webb Space Telescope was ready to go. The telescope was launched from French Guiana at the Guiana Space Center. It had to be folded completely for the trip. The next time it unfolds, it will be in space. This time, they had to modify the shipping container to fit the entire telescope. They called it SuperStars. We love those NASA acronyms. First, it traveled by road, pulled by a big truck, going very slowly, of course. There was some precious cargo on board. This time, instead of going by airplane, it was loaded onto a cargo ship to travel by water. It went from the coast of California, through the Panama Canal, and then to French Guiana. It took 16 days to complete the journey. This is the Ariane 5 rocket owned by the European Space Agency, which has 2 side boosters, a main stage, an upper stage, and a payload fairing. This is where the telescope was placed. The final touches were done inside the final assembly building. The telescope was lifted up, moved over, and carefully installed at the top of the rocket. Then, the payload fairing was put in place. Next, the rocket was moved to the launch pad. Going to space is risky. We have very delicate cargo that will be shaken strongly during launch. After that, it will face the cold, empty space. This is a major reason why it took years to build and test, all because there is only one chance to get it right. The Ariane 5 rocket is a proven launch vehicle, the perfect choice for such a delicate mission. The launch took place on Christmas Day in 2021. At about 2 minutes and 21 seconds after liftoff, the solid rocket boosters run out of fuel. They then detach from the spacecraft and fall back into the ocean. The main stage then lifts the rocket upward. The payload fairing detaches at 3 minutes and 26 seconds, and that is when Webb sees space for the first time. At about 8 minutes and 48 seconds, the main stage separates from the rocket. Next, the upper stage ignites. Its engine burns for about 16 minutes, putting the spacecraft on a path away from Earth. At 25 minutes, the upper stage shuts down, and shortly after, the telescope separates. It is finally on its own and on a path toward its final L2 destination. It will take about a month to get there, and during 2 of those weeks, the telescope will slowly unfold as it travels through space. All of this will be carefully watched by teams of scientists in Baltimore, Maryland, at the Mission Operations Center. Now, let's review the key steps of the deployment. First, the solar array opens up, which is very important to power the telescope. Then the high-gain antenna deploys to help communicate with Earth. In about a day and a half, the craft travels past the Moon's orbit. Next, the unitized pallet structure, or UPS for short, the deployable tower assembly, unfolds. This increases the gap from the sun shield, allowing the sensitive instruments to cool down. The aft momentum flap then deploys to help keep the telescope steady in space. Now, the sun shield opens. This delicate process took a few days to finish completely. After that, the secondary mirror is deployed, along with the aft deployable instrument radiator to help reduce the temperature. Then, the primary mirror unfolds, the port side first, followed by the starboard side. Before the telescope can be used, it undergoes mirror phasing. The 18 hexagon mirrors are adjusted with tiny movements until they are aligned perfectly. This process took many weeks. Now, the hexagons act as one giant mirror. Remember how the Hubble Space Telescope could be fixed by astronauts? With Webb, it is too far away. Similar to the Mars rover, it had to be built so well because a repair mission is not possible. James Webb has to work the very first time. The first images from Webb were released on July 12, 2022, and they were a huge success with many new discoveries. We are learning things about the universe that no one expected. As of December 2024, Webb has been working well for almost 3 years now. It cost $10 billion, was in the making for 30 years, and thousands of scientists and engineers worked together to make Webb a reality. Now, we stand on the edge of even more discoveries. What mysteries of the cosmos and of our own beginnings will James Webb uncover next? Thanks for watching this video.